In order to find the socially optimal amount of pollution or emissions there are going to be in the marketplace, we use supply and demand analysis once again, although things are a little bit different here. Notice that we have the cost on the vertical axis and we have emissions on the horizontal axis. So exactly how much pollution, how many emissions do we have within our economy? It goes from 0 all the way to E0, which is the maximum amount of pollution. So we're totally polluted at E0. This red line right here are known as our marginal damages, or MD. And this curve we read from left to right, it just tells us that as we increase our emissions, as we increase our pollution, the marginal damages, we are going to get hurt more by pollution. So our damages are increasing. More and more pollution, the more marginal damage that's going to cause. The blue line in this instance is called the MAC, the marginal abatement cost, and that's going to be read from right to left. And it tells us exactly how much is it going to cost us to clean up emissions or pollutions. So if we clean up zero pollution at all, where we're totally polluted in this instance, we have zero marginal abatement costs. However, if we clean up more and more pollution, we notice those costs becomes very high as we get closer and closer to zero emission or zero pollution. So here we read this curve from right to left. So a little bit different from our typical supply and demand analysis. And using these two curves, we're going to be able to conduct our marginal benefit and marginal cost analysis. So let's go ahead and take a look at the typical supply and demand analysis here. First, we go ahead and focus in on the marginal abatement cost. Marginal abatement cost. Abatement cost. So that's that MAC that we just saw. The MAC. It tells us exactly how much we need to pay in order to reduce emissions. So cost associated with reducing emissions. Reducing emissions. So here, that's going to be that curve that we saw that's read from right to left. This blue line right here. As we clean up more and more emissions, as we get lower and lower amounts of pollution, our costs are going to rise upwards. So if we want to be having a situation where we have zero pollution, it's going to cost a lot of money to do so. On the other hand, we have the MD, the marginal damages, that red line right there, and these are changes in damages that come from a given change in emissions levels. So next, the marginal damages. Marginal damages. That's MD for us. So marginal damages, as we said, changes in damages that come from a given change in emissions level. So changes in damages that come from a given change in emissions levels. So exactly how much damage is society facing when we increase the pollution or emissions cost. So here, let's go ahead and focus in on this, marginal damages. We read this from left to right. It just tells us the more and more emissions or pollution that we have, the higher the damages are going to be. So let's go ahead and suppose that we're operating at E1 emissions or E1 pollution within the economy. Why would something like E1 not be our socially optimal amount of pollution? Well, because we notice that at this point, the marginal damages is greater than the marginal abatement cost. So we're suffering a lot in terms of society, in terms of pollution, but the cost to clean up the pollution is still relatively low, or it's less than the cost of the damages right here. So it would make sense for us to go ahead and clean up more and more pollution in order for us to gain the benefits from this abatement. So here, something like E1 would not be seen as our socially optimum level because MD, the marginal damages, are bigger than the marginal abatement cost. And like we said, we want to go ahead and reduce or clean up emissions if this is going to be the case. So if anytime marginal damages are greater than the marginal abatement cost, then you want to go ahead and clean up or reduce emissions from that current level. However, what happens if we have the opposite case, where marginal damages are less than the marginal abatement cost? What do you think we're going to do in this scenario? So in this situation, we'd be somewhere over here, where we have, say, maybe E3 in this instance, or E2. And this is where marginal abatement costs are very high, but the marginal damages, that cost is very, very low. And once again, this would not be seen as our socially optimum level of pollution because we notice that the cost of cleaning up this pollution is very, very high compared to the damages that it's actually causing. So therefore, we've actually spent too much on pollution cleanup, and we could have done better by sort of not by actually polluting more in this instance. So it might be weird to say that, hey, why do we want to increase our emissions? In this instance, we note that the cost of cleaning up is much greater than the benefit that we get or the cost that's being caused by these marginal damages. So in this instance, we want to go ahead and do the opposite case where we increase emissions. Increase emissions. So we have these two scenarios where if marginal damages are greater than marginal abatement costs, we want to reduce emissions. But if marginal damages are less than the marginal abatement costs, we should increase emissions. So where's the socially optimum point going to lie? It's going to be exactly at the intersection of the MAC and MD curves where they're exactly equal to one another, where the cost of cleaning up is exactly equal to the cost of the damages of the pollution. And notice here, we have a socially optimum level of pollution that's equal to ES. So in economics, the goal is not to actually reduce pollution or emissions all the way down to zero because the cost of doing so would be extraordinarily high. Here, we have some type of positive amount of emissions at the socially optimum level, and that's something that you're going to see in a lot of environmental policy. So here at the socially optimum point where MAC equals to MD, the costs are exactly equated to one another, and we still have some positive amounts of pollution here. So an ES level of carbon dioxide or some type of emissions or pollution within our economy. Once again, this is just going with our supply and demand analysis, equating some type of marginal damages to some type of marginal benefit, or the marginal benefit and marginal cost, and seeing exactly when these 2 points are equal to one another. This is exactly where society is going to be best off, increasing the welfare and efficiency within the entire marketplace. In order to see this a little bit more in application, we're going to focus in on two different policies that countries may be able to pursue in order to reach this point. We can focus in on command and control, or we can focus in on more market-based policies, and we're going to see exactly which method is going to be better for us or for any country.